Welcome to Technovation. I'm your host, Peter High. My guest today is Andres Rodriguez. Andres is an Intel fellow. In that role, he provides technical leadership across Intel for artificial intelligence, software libraries, and hardware products. He also works with the company's customers to accelerate their AI workloads with Intel's hardware and software. As such, he helps drive remarkable innovation on behalf of his company. Andres has been with Intel for more than 6.5 years and was formerly an adjunct professor at Wright State University, a research scientist at the Air Force Research Laboratory, and he spent time as a research assistant at both Carnegie Mellon University and at Brigham Young University.
Andres Rodriguez, welcome to Technovation. It's great to speak with you today.
Great to be here, Peter. Thanks for the invite.
That's a pleasure. Andres, you are an Intel fellow, a role you've had for a bit more than half a year from across your more than 6.5 years at Intel Corporation. Perhaps we begin, if you don't mind, with a description of what it entails to be an Intel fellow. What's within your purview, please?
So what I do is I lead a global team of AI optimization engineers, and we work to make sure that our customers' code runs efficiently on Intel's hardware. So that's one aspect of the work that I do. Another one is I work closely with our AI software products team to make sure that the products that they are developing in software meets what our customers need. And I also work with our hardware teams to co-develop new features that are beneficial for AI for the future hardware that we are developing. So I get to work with both our customers, with our software teams, and with our hardware teams, providing technical guidance on what Intel needs to do to make us successful in AI, and so that our customers are pleased with the products that they're receiving from Intel.
Andres, I wanted to take a moment and talk about the hardware side of your purview. So many people, of course, think about AI as primarily a software-centric discipline, but you get so deeply involved in the hardware side of that within Intel. And in the broader ecosystem of companies, there are a great number of them that are making significant investments from a hardware perspective. First, maybe take a quick moment to define the landscape a little bit more and talk a bit about the bets that you and they are making, at least those that you'd like to shed a light on.
Certainly. So Intel, as well as many other hardware vendors, both established and startups, are investing significantly in advancing our hardware for AI. And there are different trade-offs that you can make. On the one hand, you have general purpose CPUs that are very good at many various tasks, but have probably the highest power for performance cost compared to dedicated accelerators. So what are some of the trade-offs that hardware vendors are making? On the CPU side, both Intel and other CPU vendors are improving the AI performance by adding features that can accelerate artificial intelligence operations. One of the most common features is general matrix multiplications, or GEMs. And so Intel is adding an accelerator to every core in the Xeon server line, starting with the generation that's going to be launching later this year, codenamed Sapphire Rapids. In addition, we at Intel, we're developing a GPU for artificial intelligence with a lot of compute, particularly accelerating general matrix multiplications. This is similar to what NVIDIA is doing with their server GPUs. And not just NVIDIA, but as other companies like AMD. In addition, some companies, Intel included, are developing dedicated accelerators. So Intel, we actually acquired a company called Habana Labs, and Habana Labs developed a dedicated processor known as Gaudi for training, which is available to the public at Amazon Web Services. Google developed a dedicated processor called the Tensor Processor Unit, or TPU, available at Google Cloud Platform. And other companies likewise are developing similar AI dedicated processors. The trade-offs that you make with these dedicated processors is that you are using most of the silicon space for compute, and you take away some of the general purposeness capabilities that, for example, a CPU has. What this means is that you are moving some of the complexities in the hardware to the software. And this is the biggest trade-off that these dedicated AI processors make. Hardware today in our general purpose CPUs, they simplify a lot of the complexities that the software would have to make. So for example, the hardware often has built-in intelligence logic to prefetch the next set of data. Dedicated processors, they don't have that typically. And so that complexity is left to the programmer. So the programmer has to be very, very careful in making sure that the data is carefully mapped to the compute that is available in the processor. And if this mapping is done incorrectly, then the large compute capability of the dedicated processor goes unused. So the trade-off you're making is hardware complexity versus software complexities. Now, the bet that dedicated processors are making is that the software complexity in the next few years is going to be easier because of dedicated deep learning compilers. So what this means is that dedicated deep learning compilers are going to do this mapping from the code to the compute in a manner that is efficiently, so that you don't require all the hardware complexities. A software compiler can make this mapping. And so once these deep learning compilers mature, then the dedicated AI processors will be able to efficiently take advantage of the code that the programmer writes without having an expert optimization engineer do this mapping for you. So that's what I anticipate is going to be in the future, in the next few years. Deep learning compilers mature, which will facilitate the adoption of AI processors. But still, we'll see. That's the main bet that dedicated AI processors have, that deep learning compilers will facilitate the usage of those platforms.
Wonderful. And talk a bit about the team that you lead, if you would. What sorts of backgrounds do your fellow team members have in order to help innovate around a topic that has a great deal of complexity, artificial intelligence, especially its applications, as you point out, both from a hardware and software perspective?
So one of the principal deliverables that our team is tasked to do is to map our customers' AI code to our hardware in a manner that takes advantage of our hardware features. So one of the key requirements is to have an optimization background. So understanding our hardware and how to efficiently use the various features that our hardware offers. So for example, our CPUs, they have a single instruction, multiple data, they have multiple registers, they have a fuse multiply execution units in the core. We have multiple cores, we have a cache hierarchy. And so we need the code to be written in a way that takes advantage of all the parallelism opportunities that our hardware can deliver, and that we reduce the memory to compute traffic. This is actually one of the main bottlenecks that we typically observe, not just in AI, but in many types of performance optimization work that Intel does for our customers. So we want to reduce the data transfer from memory to compute, which means we want to reuse a lot of the data that's already in the compute. And so mapping the code in such a way that you can reuse as much of the data as possible and reduce the memory to computer transfer is one of the key deliverables from our team. In addition, our team needs to understand artificial intelligence algorithms, so keep up with the latest work that our customers are doing so that they can have very intelligent discussions with the customers and understand, in some cases, modifications that they can do to the algorithms themselves in order to make them more friendlier to our hardware.
That's a great overview. Thank you for that. More generally speaking, I wonder if you could talk about progress made on artificial intelligence. It's a topic that is raised so often these days. It is a priority for many technology executives as well. Though, of course, depending upon the company and the executive, organizations will be at very different levels of maturity relative to the topic. As you contemplate progress made across your career in artificial intelligence, as well as the progress you're excited about in the near and medium term, where would you say we are in the evolution of artificial intelligence?
It's an exciting area to be involved in artificial intelligence. Just to give you a short history, there's been a few waves, three main waves in artificial intelligence. It started in the late 50s, early 60s, for simple problems like binary classification. And binary classification means you're trying to make a decision between two types of choices, such as, hey, is this a cat or a dog? Is this a tall person or a short person, a tank or a car, etc. But it didn't deliver on the hype that it had. And so you had what is known as the first AI winter in the 1970s. And this lasted for about a decade until in the 1980s, there were some new algorithms that were developed and known as backpropagation that allowed the training of much more complex AI models. And so this generated a new wave, a second wave of excitement around artificial intelligence. However, these algorithms require much more compute and require a large amount of data that at that time weren't readily available. And they were replacing industry. These types of algorithms were replaced by more simpler algorithms, such as support vector machines that required less data to train and that were simpler to understand. They had some theoretical guarantees than the neural network types of algorithms. And so this was a very slow time of growth in the area of artificial intelligence with very minor incremental gains up until like the 2010 period, when now that we have large amounts of data sets and large compute capacity, there was a third wave of excitement around artificial intelligence with the coming back of neural networks. And neural networks have been used now for a variety of tasks over the past decade. They became repopularized through computer vision applications. So to be able to detect various objects and to classify those objects. And if you look at like the technology that you carry in your pocket, in your smartphone, and whenever you take a photo and it gets processed, you can often the algorithms know where people are, who their faces belong to. This would have been an extremely challenging task 10 years ago with the algorithms of that time. Also in speech recognition, in machine translation, translated between different languages, the amount of progress is unbelievably fast over the past few years. Similar in the area of recommendation models. So whenever you want to purchase a product or when you want to watch some movie, the algorithms that are recommending these products are leveraging neural networks. So we're in a time where neural networks are increasingly becoming part of many industries. And so it is a pretty exciting time to be in this field. You ask, what can companies do, especially the smaller companies? The larger companies the internet giants, they have access to large data sets. They have a very large data centers that they can leverage to train these algorithms. But what about the smaller ones? So fortunately, there is a new set of algorithms that target smaller models. So you can actually take large models that have been trained with very large amounts of data, and then you can retrain them or fine-tune them for a particular task. So if you're a small business that does not have a very large data set, you can take a large model and retrain that large model with your smaller data set for your particular task. You can also leverage a number of tools. Intel, as well as other hardware vendors, as well as the public cloud service providers, are providing end-to-end tools to facilitate the data pre-processing, post-processing, and training of AI algorithms. And lastly, I think there is a desire to apply AI to everything, but working with your data scientist, I think it's really important to identify the areas in your business where AI can make the biggest impact, whether it is maybe in human resources or in manufacturing or whatever areas your business is trying to resolve. Just work with your data scientists to identify those ones where the low-hanging fruit, where AI can make the biggest difference.
A great overview. Thank you so much, Andres. And you've spoken about how AI is getting more democratized in the process as well. Talk a bit about what you mean by that and what that entails, building on what you've just described, please.
Intel, as well as other companies, are developing tools to facilitate the broad market to use AI. So back in 2010, 2012, in the early days of this new wave of AI, you needed experts that understood very, very well the hardware and that understood AI, the algorithms, that could map the algorithms to the hardware in a manner that was efficient. And you had to write all the code of these AI functions by scratch using C, C++ for CPUs, or CUDA C, CUDA C++ for the GPUs. And only few companies had the capability to hire all the experts that require building these AI algorithms. Today, though, we have software libraries that abstract a lot of these complexities. So you can develop an AI algorithm just by using high-level functions. So you can think of an AI algorithm as a set of Lego pieces that you put together to build complex models. And leveraging AI libraries such as TensorFlow, which was and is maintained by Google, such as PyTorch, which was developed and is maintained by Meta, you can abstract the low-level complexities and just focus on these high-level building blocks to design your model. In addition, there's a lot of effort that goes into preparing the data set before you train these algorithms or before you deploy them. And there are now tools available by Intel and others to more easily do the data cleaning, the data preparation, making sure that the data is in a format that the AI models can consume them. And so you have a pipeline that is available today, from data pre-processing to post-processing and everything in between, that is available to the broad market, which wasn't a few years ago. So this is democratizing the adoption of AI across the industry. In addition, you also have the availability to leverage high-level tools. For example, public CSPs offer AI as a service, where they take data, they train complex models, and then you can leverage those complex models with just simple APIs. So you don't even need to understand any of the complexities behind the AI models if you want to stay at that high level. So for example, you can leverage like an image classifier without actually training a model, just leverage an existing model that a public CSP trained for you. Similar with machine translation, you can take a document from one language to another language without understanding any of the complexities behind it. So depending on the level that you want to work on, there are different tools or software libraries that the industry can leverage.
It's very interesting. I think what was intimidating for many, Andres, was the prospect of developing artificial intelligence within one's own team primarily. And what I'm hearing you say is there are great opportunities now to develop a robust ecosystem. In addition to open source style software that one can access readily and cheaply, if not for free, in order to make significant progress from this perspective. Is that a fair synopsis?
That's correct. One of the exciting things about this community is the willingness to open source software and to share the learnings. It is fascinating going to an AI conference and seeing two competing companies publishing details about the AI algorithms that they're using in production. And so there is a lot of information sharing at the algorithm level and at the software level. And I think this is one of the reasons that AI progress is moving so fast, because of all the knowledge sharing that is happening.
Very interesting. I appreciate that overview as well. As someone who works across the ecosystem within Intel, as well as across customers of the organization as well, I'd be interested in understanding some of the best practices in terms of training and ensuring that organizations are primed well to take advantage of what's being built. Can you talk a bit about that as well?
Yes, when you are taking AI algorithms and deploying them in production, you need to train them, and this requires often large amounts of compute. And so companies are developing dedicated AI clusters to train these large algorithms. So this is primarily the internet giants. The best practices for these internet giants is a bit different than the best practices for medium to small businesses. So to start with the internet giants, they are developing clusters with hundreds and thousands of servers to train one single AI algorithm. And what they are doing is they have to focus on not just the server itself, but the entire dedicated data center for AI. So they have packets within their data center that require high-speed interconnects in order to be able to train these algorithms efficiently. So when you're training these large models, you have to distribute the compute across the many servers in your clusters, often hundreds or thousands of servers. And so this requires high-speed interconnects to efficiently distribute all the compute across these servers. For medium to smaller businesses that are leveraging the large existing models, they can take these large models and they can apply some techniques to make them smaller. They're called distill them into smaller models and then retrain them or fine-tune them for their particular task. And so what they need is they need to have data for that particular task. And often both large companies and small companies need to spend resources labeling the data. This can be a costly process to take unlabeled data, such as images, and put in a label to them. So for example, this image belongs to a class person, this image belongs to a class vehicle, or much finer grain, this belongs to this particular vehicle or this particular person, etc. So just developing clusters of AI dedicated servers for large models, it's one of the beginnings for the large companies. And then taking advantage of these large trained models and knowing how to distill them into the smaller models is a key BKM for the smaller and medium businesses.
Interesting. I appreciate that overview as well, Andres. And I know that you and your team think a lot about artificial intelligence, of course, as a net benefit to society, but you also bear in mind some of the potential risks associated with it as well. Can you take a moment and talk a bit about your own perspectives of the balance between those and ensuring that as decisions are made for the short or medium term, the longer term implications are also taken into consideration appropriately?
So I'm very optimistic about the benefits that AI is bringing to society. I think it's connecting the world, helping us communicate better. I look forward to the day where I can talk to a person in China and I can speak in English or in my native tongue, Spanish, and they'll hear me as if I was speaking Chinese, and vice versa. They'll speak in Chinese and I'll hear them as if they were speaking English. And we're close to getting there. All the technology pieces exist to make this possible. It's just the latency, it's not quite there to make the communication smooth. In addition, AI is bringing advances in medicine, being able to find cures for new diseases. I think AI is going to accelerate these discoveries. I do think there are some areas where AI can have a negative impact in society. I'll mention a few. One of the main concerns is the society divisions that AI can create. There is so much content personalization that we end up living in bubbles where we are fed content that reinforces rather than challenges our beliefs. And a clear example of this was the large divisions that we observe with the COVID vaccine, where some people strongly felt that it was so critical for everybody to get the vaccine, while others thought it was dangerous. And both groups are making those decisions based on the information that they are being fed, that they're consuming. And it also creates tension between both groups. One group thinking that the other group is wrong. We see this much more also in various political aspects of our lives. And so it's creating a society that is much more divided. And I've thought about what is response? What can companies do to mitigate this? And it is quite difficult. These algorithms are trained with a metric of success. And as you're developing these algorithms, you have to think, what is the outcome that you want to accomplish? And what is a mathematical way to represent the outcome? So for example, one possible outcome is you want maximum engagement with the platform, with a given platform. And so a mathematical way to represent that could be the click-throughs, the number of clicks that you get. So that's a simple metric that you can maximize for. It might not be the best metric for society, but it is simple to implement. Having a metric that represents maximal society benefit, it's very hard to come up with such a metric. So I don't necessarily have a good solution. I do work with a number of AI engineers across social media companies, and they are great people to work with. They have the desires to improve society, and they are aware that they're tackling a very difficult challenge. So that's one area of concern. And unfortunately, I don't have a clean recommendation on how to tackle that one. A second issue that I see is the demand for more power consumption. So as these models continue to grow in sizes, they require much more power. You can think of a modern data center requiring perhaps around 100 megawatts to operate. And if you want to increase the accuracy of these models, then the accuracy doesn't linearly increase with power. significantly more power is required to increase just a little bit of the accuracy of these models. In fact, there was a paper written by Thompson and some of his colleagues at MIT about 2 years ago that showed that power growth at the 4th to 9th power correlated with accuracy. So if you want to double your accuracy, you need to increase the power consumption by 16 to 512x the amount of power. So the amount of power, it's a concern because of the potential climate consequences. And as we, as a society, becoming much more aware of the footprint that we live in our environment, we need to think of how do we tackle the hunger for power that these models have. And so some of the ideas is taking large models and train them very infrequently and distilling them or making them smaller prior to production. And this is something that it is happening today. Another thought is applying machine learning for deep learning model design, which means finding deep learning models that are not as large, but yet can deliver on high accuracy. And this is an area known as AutoML, which looks very promising. And this can maintain a high accuracy from these models without requiring them to grow as large as they would need to grow without applying machine learning techniques. So that's a second area of concern. And the last area is more related to copyright. So for example, I don't know if you watch, if you're a Star Wars fan, but in the original movies, there was one of the characters, Grand Moff Tarkin, earlier known as Captain Tarkin, who was played by an actor that passed away in the 90s, Peter Cushing. And in the recent movie, Rogue One, the actor showed up in the movie. Of course, it was a CGI creation, and but you wonder, hey, is this okay? Is it okay to bring actors that were not real in the movies to be portrayed in the movies? Now, how does this relate to AI? In AI, you have the ability nowadays to very realistically generate fake people that look very much real and resemble and can resemble a particular real person. And you can generate their voice. You can have their mouth movements very precisely synchronized to what they're saying. And it doesn't require the huge budgets of Hollywood to make this possible. Researchers at universities are making this possible. So dealing with the implications of perhaps an actor's willingness or unwillingness to be portrayed in those scenarios. Another one similar is in the area of music. So for example, let's say that you are a composer and you have many beautiful pieces that require significant effort for you to compose. An AI algorithm can quickly look through all your music and then be trained and create music that resembles your style. And it's going to take the algorithm very little effort to do so. Is that going to be, is that okay or not? So I think this is where government can play a part in protecting the copyright of creators to make sure that if an AI algorithm uses their creations in their training to generate new music, that they can somehow be partially compensated for that. Again, I'm not a government policy expert. This is just some high-level ideas of some of the areas that government could facilitate the protection of creators.
Very interesting. I also wanted to ask you, there are a lot of people who are leaders in this field who have backgrounds akin to yours. You have a PhD from Carnegie Mellon, one of just a handful of universities that are on the bleeding edge in terms of innovation relative to this topic. As you were talking earlier about the democratization of artificial intelligence, talk about the ways in which you believe a non-technical person, a non-engineer even, might be able to do creative development in artificial intelligence and how far off that might be as well. Do you see some sort of citizen developer attributes developing here in the near or medium term that will impact our own ability, those of us who do not have PhDs from elite institutions related to these topics? How do you see that evolving, please?
Yeah, certainly. In fact, at Intel, and it is my observation elsewhere, we want to grow our AI talent, and we provide trainings to non-AI engineers to bring them into AI roles. I think people see AI as some mysterious field that requires a PhD from a top university. And I think that was the case 10 years ago. But today, the tools are so readily available that you don't need to have this high level of expertise in AI to be able to use AI, to be able to create models. I teach a 2-day class at Intel to non-AI engineers. And by the 2 days, they're able to train simple models. They're able to gain familiarity with the AI software libraries like PyTorch and TensorFlow. And using PyTorch, they create models for simple image classification tasks. Now, this is just with 2 days of learning. If they continue to apply that over a few months, then they can start training much more complex models. My observation, even in academia, is you have a student with little AI expertise that starts their PhD program, and sometimes in 1 or 2 semesters, they're publishing a research paper. Again, the ability to get your feet wet and start contributing does not require the time that it used to take, thanks to all the software tools, all the knowledge sharing that is available. When I was at Carnegie Mellon, and I don't know if they do this still, but every student had to take a computer science coding class. It didn't matter if you are a music major, a theater major, everybody had to come out of the university with at least one coding class. And this is because Carnegie Mellon wanted to be seen as a leader in computer science. And similar, I think industries, I'm not necessarily suggesting that every employee needs to take an AI class, but there is the opportunity to learn about AI. There are courses that are freely available that doesn't take many hours to complete. So a large portion of some companies that want to gear and become more AI companies, they can invest, they can provide their engineers a lot of time for them to take AI classes and to become familiar with the tools. It is a time where AI knowledge is being democratized, and so it's not a niche anymore. It's something that people can widely access, and they are. And I've seen this at Intel, where people that were not doing AI 2-3 years ago are now leading some of AI projects, AI tasks. The learning curve, it's much smaller than it used to be.
Well, Andres Rodriguez, thank you for a really dynamic conversation, tackling an important topic that is only rising in terms of its prominence in the technology and digital community, but the topic certainly that's going to impact us all, as I think you've made an important case here in our conversation. It's been great speaking with you today. Thank you again.
Thank you, Peter. I really enjoyed it.